There is something down there that has never seen sunlight. Not once. Not for a single second of its entire life. And right now, as you settle in and let your body grow heavy, somewhere beneath roughly 4 kilometers of dark water, something the size of a city bus is drifting through a world that most humans will never even come close to experiencing. It breathes differently down there. It moves differently. The rules that govern everything you've ever known, pressure, temperature, light, they simply do not apply. And here's the part that should stop you cold if you weren't already so comfortable. We know more about the surface of Mars than we do about the bottom of our own ocean. Let that settle for a moment. The ocean has layers. Not in the vague, poetic sense people mean when they say something has depth. Real, measurable, almost impossible layers, each one darker, colder, more crushing than the last. And the creatures that live in each zone didn't just wander there by accident. They were shaped by those depths, sculpted by pressure and darkness over millions of years into forms that, honestly, shouldn't be able to exist. The sunlight zone is where everything familiar lives. Dolphins breaking the surface, tuna cutting through blue water, sea turtles navigating by magnetic fields they can feel but never explain. Here, down to about 200 meters, photosynthesis is still possible. Energy flows from the sun into the water column, and the whole base of the food web hums along in a kind of golden equilibrium. Then the light starts thinning. By the time you reach 200 meters, red wavelengths have completely disappeared. The world has turned permanently blue-green, and already the animals here have begun their strange negotiations with darkness. Some of them carry mirrors inside their eyes, biological reflectors that gather every last photon they possibly can. Others have simply given up on vision entirely, trading eyesight for chemical sensitivity so acute that they can detect a single molecule of blood dispersed through an Olympic swimming pool's worth of water. But that's only the beginning. And you should know the beginning is the most ordinary part of this story. Somewhere around 500 meters, the water temperature drops below 10 degrees and refuses to climb back. This is called the thermocline, and crossing it is less like passing through a gradient and more like stepping through a door that closes behind you. The pressure here, 15 times what you feel at the surface, would collapse an unprotected human lung in roughly the same time it takes you to exhale. The creatures here don't notice. They were born in this. One of the strangest things that happens at this depth is something called bioluminescence. And while that word gets used constantly in ocean documentaries, what people almost never explain is just how differently these animals use it. It's not decoration. It's not accent lighting. Some deep-sea shrimp produce a cloud of glowing chemicals when threatened, a luminescent smokescreen essentially, and then vanish into the dark, while whatever was hunting them remains temporarily blinded by the unexpected flash. There's a fish called the dragonfish, the black dragonfish specifically, that has gone even further. It produces red bioluminescence, and while most deep-sea creatures can't see red light at all, the dragonfish has evolved unique photoreceptors in its eyes that can. The result is a hunting scenario almost too elegant to believe. It carries its own private red searchlight that is completely invisible to its prey, cruising through absolute darkness with a spotlight only it can see. The ocean invented stealth before humans had the language to describe what stealth even was. You are drifting now. Let the weight of your body press gently into whatever surface is holding you. There is no urgency here. The next thought will come in its own time, and the one after that will come even slower. Below 500 meters, below 1,000, something about the relationship between size and depth begins to reveal itself, and it is deeply, beautifully strange. Scientists call it deep-sea gigantism, The formal explanation involves cold temperature slowing metabolism, high pressure affecting cellular chemistry, and low food availability, creating evolutionary pressure toward a body that can survive long periods without eating. But those are just words that try to fit something genuinely alien into human categories. What it actually looks like is this: the isopod, a creature that at the surface resembles a common pill bug, the kind you'd find under a rock in any garden, reaches 1.5 feet in length in the deep ocean. The same basic body plan, the same armored segments, the same rolling into a ball defense mechanism, just multiplied by 15 in a world with no good reason to exist at all. There are giant squid down there, architeuthis ducks, with eyes the size of dinner plates. Not the biggest eyes in the ocean, though. That distinction goes to the colossal squid, Mesonicoteuthis hamiltoni, with eyes that, in the largest recorded specimens, approached 30 centimeters across. Eyes that can detect bioluminescence from a sperm whale diving to hunt it, giving the squid just enough time to decide whether to flee or to fight. And sperm whales do dive for them, regularly, descending over 2 kilometers in a single breath, navigating by sound in the complete absence of light, their clicks echoing off bodies they cannot see. Sperm whales have been found with scars from colossal squid suckers, rings of tooth-like serrations that leave circular marks on whale skin, the way a cookie cutter leaves an impression in dough. These marks are proof of battles happening in total darkness, between 2 enormous animals, at pressures that would kill anything not specifically built for it, in a part of the ocean that no human being has ever directly witnessed. That fight is happening somewhere right now. The midnight zone begins at 1,000 meters, and this is where the rules truly stop applying. No light has ever reached here naturally. None. The only illumination in the midnight zone is what the animals themselves create, and they create it constantly, for reasons that took biologists decades to begin untangling. Roughly 70 to 80% of deep-sea creatures produce some form of bioluminescence, which means the midnight zone isn't actually dark in the way you'd experience darkness in a closed room. It's dark the way a city seen from orbit is dark. Technically no sun, technically nighttime, and yet persistently, quietly, alive with points of light that have nothing to do with stars. The anglerfish lives here. And while the anglerfish is probably the most recognizable deep-sea creature, the one with the glowing lure dangling above its enormous hinged jaw, almost nothing that most people know about it captures how genuinely extraordinary it is. The lure itself, called the esca, is not just a light. It's a bacterial colony. The anglerfish can't produce its own bioluminescence. It maintains a symbiotic relationship with specific species of bacteria that live inside the lure's tip, creating light in exchange for the shelter of the fish's body. But the anglerfish controls the bacteria, regulates them, can apparently dim and brighten the lure through muscular pressure on the surrounding tissue. The relationship is so old evolutionarily that the bacteria have lost the ability to live anywhere else. They exist only inside anglerfish lures. They cannot be cultured in a laboratory. If removed from their host, they die within hours. 2 living things so thoroughly committed to each other that neither can survive alone anymore. Let your breathing slow just a little more. There's nowhere to be. The stories down there have been unfolding for 300 million years, and they'll still be unfolding long after this night is over. In the Mariana Trench, the deepest known point in any ocean on Earth, the pressure reaches 11,000 pounds per square inch. At that depth, water itself behaves differently. It becomes slightly more viscous. Sound travels through it faster. And yet there are creatures there. Single-celled organisms called foraminifera build intricate calcium shells in shapes that look almost architectural, spiraling, branching, precise, and they drift through the trench sediment in numbers so vast that the bottom of the Mariana is partly made of their accumulated shells. 10,000 meters below the surface, and life is not just surviving there, it is, by all appearances, thriving. There is a type of snailfish, Pseudoleparus swiri, that was only formally described in 2017, found at nearly 8,000 meters, pale and almost translucent, moving through the water with the unhurried confidence of an animal that has no natural predators, because nothing else in the world can survive where it lives. Its bones are partially unfused, which allows its body to flex under the enormous pressure rather than being crushed. It doesn't fight the deep. It accommodates it. It has become, in every biological sense, a creature of the deepest possible dark. These animals never panic. Nothing down there does. Panic requires adrenaline, which requires a threat response, which requires a nervous system operating at surface world speed. The deep slows everything: metabolism, movement, heartbeat, reproduction. A Greenland shark living in the cold, dark waters of the North Atlantic can live for 500 years. 500. Born before the Mayflower sailed, dying after things we cannot currently imagine have come and gone. Moving through the same dark water, generation after generation of humans coming and going above it, and never once surfacing into the world those humans consider real. Time moves differently when pressure is the only constant. There is a sound in the deep ocean that was recorded in 1997 and given the name the bloop. It was extraordinarily loud, loud enough to be detected by hydrophones over 5,000 kilometers apart, and for a period of years it remained genuinely, frustratingly unexplained. Scientists eventually concluded that it was the sound of a massive ice quake, the fracturing and movement of an enormous section of Antarctic ice shelf, amplified by the deep sound channel in the ocean, a natural acoustic waveguide that funnels sound horizontally across the entire Pacific Basin. But for those years of uncertainty, it represented something that doesn't get acknowledged often enough. The ocean holds sounds we don't recognize, not because they're alien, but because the ocean is vast in a way that makes our instruments feel like cupped hands trying to catch a waterfall. The deep sea recording equipment we have can capture everything in a fixed radius. What's outside that radius? Nobody knows with any certainty. New species are still being discovered every year. Not microbes, not bacteria, but macroscopic animals. Actual fish, actual squid, actual creatures large enough to see with the naked eye, in a part of the world we've been sailing over for thousands of years. There is more mystery in the ocean than the ocean has space for mystery. And right now, as your body relaxes and your thoughts begin to soften at the edges, that mystery is still there, ongoing, unsupervised by human understanding. The deep is doing what the deep has always done, with or without anyone watching, with or without a name for any of it. The twilight zone. The mesopelagic performs one of the most remarkable daily migrations in the natural world, and almost nobody talks about it. Every single day, billions of small fish, squid, and crustaceans rise from depths of 200 to 300 meters toward the surface as the sun sets, feeding in the relative richness of the upper ocean, while darkness provides cover. Then, as dawn approaches, they sink back down. This migration, called the diel vertical migration, is the largest animal migration on Earth by biomass. It happens every single day across every ocean simultaneously, and it moves so much carbon from the surface to the deep that it meaningfully affects the global climate. These small creatures, carrying carbon they've absorbed from surface-level organisms, sink with them, or excrete it in the deep water, where it won't reach the atmosphere for decades or centuries. The ocean's small, unremarkable-looking residents are quietly running a carbon sequestration system that rivals anything humans have designed. They're not doing it intentionally. They're just eating and hiding and trying to survive. But the consequence, at planetary scale, is staggering. There's something about the sheer weight of water above that reframes every thought. Right now, without moving, without effort, you are being pressed by the atmosphere roughly 14 pounds per square inch, always, in every direction. You don't feel it because you were born into it. You are calibrated for it so precisely that removing it would kill you as surely as the deep would kill anything we dragged up too fast from its pressure. Everything alive is adapted to exactly the pressure it was born into. That's not a metaphor. That's just biology. But it's also, perhaps, worth sitting with for a moment. The anglerfish doesn't wish it were shallower. The snailfish at the bottom of the Mariana Trench isn't waiting to be rescued. The giant isopod, tasting through its antennae for chemical traces of whale fall, the carcass of a dead whale that might have drifted down from 4 kilometers up, isn't philosophizing about the surface world it will never see. There is a profound kind of peace in being exactly what the conditions around you require. Not contentment in any conscious sense, just fit. Precision fit. Body and environment so thoroughly matched that the question of whether it's a good life or a difficult one becomes, genuinely, unanswerable. The deep ocean floor is not empty. It is not featureless. It is, in fact, one of the most ecologically complex habitats on the planet, though you'd have to know what to look for to believe it. Hydrothermal vents, cracks in the ocean floor where superheated water, rich in minerals, erupts from beneath the Earth's crust, were only discovered in 1977. Before that, nobody knew they existed, and around them, scientists found entire ecosystems. Tube worms 2 meters long, clams the size of dinner plates, shrimp with light-detecting organs on their backs rather than in eyes that had long since ceased functioning in any conventional way. None of these organisms depend on sunlight. Their entire energy chain runs on chemosynthesis. Microbial organisms that convert hydrogen sulfide from the vent water into chemical energy, the way plants convert sunlight through chlorophyll on the surface. It is, without exaggeration, an alternative origin of life, a proof of concept that biology doesn't require a sun. Astrobiologists, the people who think about the possibility of life elsewhere in the universe, use hydrothermal vents as their primary reference point when imagining what might exist in the subsurface ocean of Europa, one of Jupiter's moons. Europa is covered in ice. Beneath that ice, almost certainly, there is liquid water, and beneath that water, very possibly, there are hydrothermal vents, which means that right now, the most plausible place in our solar system for extraterrestrial life to exist is modeled on an ecosystem we only discovered 48 years ago, in an ocean we've been swimming in for the entirety of human history. As you breathe slowly now, with no particular reason to breathe faster, consider that the water in your body is ancient. Not metaphorically ancient, chemically ancient. Water molecules don't get used up, they cycle. The hydrogen and oxygen in your cells have passed through cloud, through rain, through river, through deep ocean, through evaporation, through glacier, repeatedly, over timescales that make human civilization look like a brief flash between 2 long silences. Some of the water inside you right now has been in the deep ocean, has been in the absolute dark, under crushing pressure, part of an ecosystem you will never see, has been in the only meaningful sense there. And now it's here. in a body that is resting, that is warm, that is breathing slowly and allowing itself to be carried somewhere quieter. The ocean doesn't sleep, but it has a rhythm that is older than sleep, older than the concept of rest, older than any biological structure complex enough to be tired. That rhythm is still running, and somewhere in the part of you that is water, in the quiet chemical hum of a body letting go of the day, you can feel it. The ocean keeps secrets the way the earth keeps fossils, not by hiding them, but by being so patient that discovery requires an entirely different kind of attention than the kind we usually pay. Somewhere right now, in water so cold it would stop your heart before you had time to register the temperature, a species of fish is doing something it has done for 65 million years. Its body has not changed meaningfully in that time. Its behavior is essentially identical to what it was before the asteroid hit, before the extinction event that ended the reign of almost everything that came before us. And it doesn't know this. It has no frame of reference for the 65 million years. It has only now. The current, the pressure, the chemical signature of something worth eating drifting past its lateral line. Some things persist because they are so perfectly suited to their conditions that change would only be a disadvantage. The deep ocean is a museum of everything evolution decided not to fix. Let your body sink a little more into wherever it is resting. The thoughts that were circling, the ones that felt urgent an hour ago, they're starting to lose their edges. This is the part of the night where the ocean does its best work. There's a reason sleep researchers describe the descent into deep sleep as going under. It's not accidental language. The physiology of falling asleep shares a remarkable number of features with the conditions of the deep ocean. Body temperature drops. Heart rate slows, not from fear, but from the same metabolic efficiency that makes deep-sea creatures so conservationist with their energy. The brain, starved of the stimulation it runs on during waking hours, begins generating its own slow oscillations. Delta waves rolling through the cortex the way long-period ocean swells roll across the open Pacific, wide and unhurried, carrying enormous energy and almost imperceptible motion. The deep is patient, and so is the sleeping brain. One of the most unsettling things ever pulled from the deep ocean is also one of the most beautiful, depending on your tolerance for strangeness. The vampire squid, Vampiroteuthis infernalis, which translates roughly as vampire squid from hell, occupies a unique position in the tree of life. It is not actually a squid. It's not an octopus either. It represents an entirely separate evolutionary lineage that split from both of those groups roughly 300 million years ago, before the dinosaurs, before the first mammals, before the first flowers. It lives in the oxygen minimum zone, a band of water roughly 5 to 1,000 meters down, where oxygen levels drop so low that most other animals simply cannot survive there. The vampire squid's blood contains hemocyanin, a copper-based oxygen carrier, rather than the iron-based hemoglobin that runs through your veins. And this gives its body the extraordinary ability to extract oxygen from water that would suffocate everything else. It also feeds in a way no other cephalopod does. Rather than hunting live prey, it collects marine snow, the constant, slow drift of organic particles falling from the surface, dead phytoplankton, fecal pellets, the molted exoskeletons of crustaceans, fragments of dead animals, and bundles this material into mucus packages, which it then consumes. It is essentially eating the accumulation of death drifting down from above, and it does this in an oxygen-depleted zone that nothing else wants to compete in, which means it has the place almost entirely to itself. An ancient lineage in an inhospitable zone, eating what everyone else ignores. There is something almost philosophically admirable about that. The sperm whale is worth returning to because it keeps defying expectation, no matter how carefully you study it. Sperm whales have the largest brains of any animal that has ever existed on Earth. Their brains are physically enormous, 5 times the mass of a human brain, and structured in ways that continue to confuse neuroscientists. There's a region called the paralimbic lobe that is dramatically enlarged compared to most other cetaceans, and nobody is entirely certain what it does. Sperm whales have complex social structures, organized around matrilineal groups, family units led by older females who pass down knowledge through generations, in a process that looks remarkably like culture. They have regional dialects. Different populations of sperm whales produce different click patterns, codas, and these patterns are learned, not innate, which means they are transmitted culturally the way language is in humans. And then, with this large, culturally complex communicating brain, the sperm whale dives 2 kilometers in a single breath in complete darkness to fight something that has no intention of being eaten. It clicks constantly on the way down, its clicks reaching 170 decibels, louder than a gunshot, bouncing off the bodies of squid it cannot see, returning to specialized organs in its enormous head that decode the echo into a 3-dimensional map of the dark. The sperm whale doesn't see the abyss it hunts in, it hears it. It builds it in real time out of reflected sound. Then it comes back up, exhales a breath that contains the compressed residue of 2 kilometers of descent, and does it again. In its entire lifetime, a sperm whale might make tens of thousands of these dives. The ocean's relationship with time is something humans are constitutionally unable to grasp, though not for lack of trying. Consider sediment cores. When scientists drill into the ocean floor and pull up a cylinder of compacted sediment, they're pulling up a physical record of everything that has fallen from the water column above, layer by layer, century by century, sometimes going back 50 million years. The chemical composition of each layer tells you the ocean temperature when that sediment was deposited. The types of microfossils tell you which organisms were living in the surface waters at that time. It is, in the most literal possible sense, reading the ocean's diary. And what that diary shows, over and over, in every core from every ocean basin, is that the deep ocean is one of the most stable environments on Earth. Temperature at depth barely fluctuates over millions of years. Pressure remains constant. The chemical gradients that characterize the midnight zone have been essentially the same since before the continents were arranged the way they are now. Everything on the surface ice ages, mass extinctions, meteorite impacts, the rise and fall of every civilization that has ever existed. All of that happened in the thin, turbulent layer at the top. Down there, the meter didn't even twitch. Your breathing has probably already started to slow without you consciously deciding to let it. The body knows what it needs. It's been doing this far longer than the mind has been narrating it. There's a phenomenon in the deep ocean called marine snow, and it falls constantly, a perpetual drift of organic particles sinking from the sunlit surface toward the lightless floor. Some of this material takes decades to reach the bottom. Some take centuries. It is, in the most unglamorous possible sense, the ocean's food chain completing its cycle. Everything that lives and dies in the upper ocean, eventually becoming nutrient for whatever lives in the dark below. The deep sea doesn't produce its own energy at any large scale, apart from the vent communities. It lives off the rain of the dead, which sounds grim until you consider that this is precisely how forests work, how soil works, how every complex terrestrial ecosystem works. Death is not the end of a cycle. It is the point at which energy is redistributed most efficiently. The deep ocean has been running this system without interruption for hundreds of millions of years. Nutrients from marine snow fuel bacteria, which fuel amphipods, which fuel larger crustaceans, which fuel fish, which fuel the occasional sperm whale that comes barreling down from the surface in a cloud of clicks and pressure waves. Nothing is wasted. Nothing falls without being caught by something. There is an animal called the barrel-eye fish, Macropinna microstoma, that spent decades confusing scientists because its transparent head appeared to contain two small green organs positioned above its mouth, which everyone assumed were its eyes. They weren't its eyes. They were olfactory organs. Its actual eyes were the two barrel-shaped structures pointing upward inside the fluid-filled transparent dome of its head, tracking prey above it in the water column, with a sensitivity that allows it to detect bioluminescent flashes from jellyfish several meters above. When oceanographers first observed it alive in its natural environment, rather than the damaged, altered state of a dead specimen brought to the surface, they were genuinely startled. The fish was hovering, almost motionless, its tubular eyes rotating upward, the entire dome of its head gleaming with a faint biological iridescence. It looked, by multiple accounts, completely unlike anything anyone had expected. This discovery happened in 2009, not 1909, not 1950, 2009. In an age of satellites and deep-sea submersibles and genome sequencing, a fish with a transparent head full of fluid and rotating tubular eyes was seen alive for the first time in 2009. The ocean is still introducing itself. Hadal zones. The ocean's deepest trenches are not distributed randomly. They form at subduction zones, where one tectonic plate slides beneath another, creating V-shaped gashes in the ocean floor that plunge beyond the abyssal plain. The Mariana Trench is the most famous, but there are others. The Tonga Trench, the Philippine Trench, the Kermadec Trench, each of them long, narrow, and profound in ways that resist metaphor. The communities in these hadal zones are subtly but importantly different from the abyssal plain communities surrounding them. Because trenches act as funnel-shaped collectors, organic material from the ocean above concentrates in the trench walls and floor to a greater degree than on the flat plain. This means the deepest, most inhospitable places in the ocean are, counterintuitively, sometimes richer in food than the surrounding abyss. Not richer than the surface. Nothing in the deep is richer than the surface, but richer than expected given where they are. The rules at the bottom refuse to follow even the logic of the bottom. Something about extreme depth seems to select for longevity in ways scientists are only beginning to quantify. The Greenland shark's 500-year lifespan was mentioned in passing earlier, but it deserves a moment of real consideration. A Greenland shark alive today was born before the 30 Years' War, before the Salem witch trials, before Isaac Newton described gravity, before the printing press reached North America. It was alive when Shakespeare was writing his plays, when Galileo was being tried by the Inquisition for suggesting the Earth moved around the sun, when the Ottoman Empire still stretched across most of the Middle East. It has never seen any of this. It has never seen anything, really. Greenland sharks are nearly always found with cloudy corneas, parasitic crustaceans attached to their eyes that gradually reduce their vision to near blindness. They navigate through smell and electroreception and current detection, moving slowly through the cold water of the North Atlantic and Arctic Ocean, eating fish and seals and the occasional reindeer that apparently wanders too close to the ice edge. A nearly blind, 500-year-old shark, drifting through the dark, patient in a way that the concept of patience doesn't quite reach. The deep ocean is where the planet stores its memory, not just in sediment cores and microfossils, though those too, but in the form of mineral crusts that grow on the surface of seamounts at rates of 1 to 2 millimeters per million years. In the form of whale falls, the carcasses of dead whales that sink to the ocean floor and support distinct communities of organisms for decades, passing through phases the way a forest passes through ecological succession after a fire. In the form of deep water corals that grow in total darkness at temperatures near freezing, some colonies reaching ages of over 4,000 years older than the pyramids at Giza, older than most things humans regard as ancient. A coral colony that was already 800 years old when the Great Wall of China was built, still growing, millimeter by millimeter, in the dark. Let go of the need to hold any of this in a particular way. The facts don't require your concentration to remain true. The deep ocean doesn't need you to keep it in mind. Everything described tonight was happening before this moment and will continue after it, with or without a human consciousness tracking it. There is enormous relief in that, if you let yourself feel it. The universe is not waiting for your attention to proceed. One last creature before the dark takes the words too. The giant Pacific octopus, not a deep-sea animal strictly, but one that has been documented diving to several hundred meters, has a lifespan of only 3 to 5 years. In that time, a female will lay between 20,000 and 100,000 eggs, then spend the next 6 to 7 months caring for them without eating, aerating them with her arms, cleaning them of parasites, guarding them against anything that approaches. By the time the eggs hatch, she is so depleted that she typically dies within days, often consumed by the very animals she had been fighting off for months. Her final act is the hatchlings. The hatchlings are so small they're practically invisible, rising immediately toward the surface on the current, entering the sunlit zone that their mother never left the bottom to see. They will spend weeks in the plankton layer, carried by currents that may take them hundreds of kilometers from where they hatched, before eventually settling and growing into octopuses themselves. The mother never knew whether they made it. The hatchlings never knew she existed. And somehow, across millions of generations, that system produced an animal with the intelligence to recognize individual human faces, to solve novel problems without prior training, to genuinely play, in the way mammals play in ways that we can only observe and cannot fully explain. The deep doesn't give things cheaply. Everything it has produced has passed through more pressure than we can really imagine, more time than we have good numbers for, more darkness than the concept of darkness comfortably holds. The water outside, whatever water is closest to you right now, is connected to every drain and river and estuary, to the ocean shelf, to the deep, to the midnight zone and the hadal zone, and the trenches where the snailfish drift in their pale, patient way, through pressure that would stop a submarine's hull. You are not separate from any of this. The carbon in your body passed through phytoplankton before it passed through you. The water in your cells has been in the deep. The oxygen you are breathing right now was produced in part by marine algae, by phytoplankton in the surface ocean, by a photosynthetic process running across every ocean simultaneously. Right now, in the dark hours before dawn, in whichever time zones are currently midnight, the planet breathes, and you breathe with it. Everything that lives in the deep has made one fundamental accommodation. It has accepted that the pressure is not going to change, not resistance, not struggle, not the hope that if it just holds on long enough, conditions will improve. The deep sea creature has over millions of years, through the patient mechanism of selection, simply become whatever the pressure requires it to be. There is no equivalent wisdom in a conscious organism. You cannot decide to adapt. You cannot will yourself into being exactly what your conditions require. But you can, in the small human way, take one breath that is slightly slower than the last one, and then another, and let the weight of the day settle, the way sediment settles slowly, without urgency, finding the lowest possible point and staying there. The ocean floor is the lowest possible point for water, and it is, by nearly every biological measure, full of life. Somewhere between 4 and 5 kilometers below the surface of the Pacific Ocean, in water colder than a refrigerator, under 11 million pounds of pressure per square meter, a small fish is moving, not hurrying, not resting exactly, because sleep as you experience it doesn't quite apply to something operating at that metabolic rate, but moving slowly through the dark with no awareness of your existence, no awareness of the surface world, no awareness of any of the things that feel, from up here, like they matter so much. It has what it needs. It is where it belongs. The dark is not threatening it. The pressure is not punishing it. The cold is not something it endures. All of these things are just the texture of the world it was made for. The specific, improbable, perfectly calibrated world that produced it, and that it, in some small way, helps sustain. You are somewhere warm. You are somewhere safe. The pressure of the day has been exactly as much as you could carry, and you have carried it, and now you can set it down. The deep ocean keeps going without you, and you can rest. Let the dark be what the dark is, not an absence, but a presence. Not emptiness, but the oldest, most patient, most vast place on this planet, going about its ancient business, indifferent and magnificent, and full of things that have never once needed the light to know exactly who they are. Sleep now. The deep is already there.